Have you ever walked outside and noticed that the buildings around you just keep getting bigger? I'm Frederick Bolchok, and today I'm talking about that material that helps engineers build taller, safer, and more efficient structures. As buildings rise higher, we can't rely on only old systems like plain old concrete and steel. We need something that's stronger, more efficient, and that's why composite concrete steel systems are becoming one of the best options for modern high-rise structures. Right now, engineers use materials like concrete, steel, and masonry. Concrete is strong but very heavy. Steel is light but fast to install, but can bend more under heavier loads. Masonry looks great, but it takes a long time to build with each material. So each material has their own strengths and limitations. To solve these problems, engineers have developed composite systems. These systems combine concrete and steel so that strengths of each material work together in this video. In this video, I'll compare concrete, steel, and composite systems to show which one performs the best for tall buildings. Let's start with RCC, or reinforced cement concrete. RCC is one of the most common materials in the modern world. It is strong in compression, but also very light. That weight increases the size of the foundation and slows down the construction time. Steel is much lighter and can be made off-site, which saves time and labor, but steel alone can sway more in the wind, which isn't ideal for very tall buildings. Masonry, like brick, is heavy and slow to install, but gives buildings a clean and classic look. This is where composite concrete steel systems come into play. They combine steel on the inside with concrete on the outside. I reviewed a case study comparing two 22-story buildings built with different materials, and the composite systems clearly perform better. When comparing these two structures, you found that while the time to operate with the one specific material mattered most because each material behaves a specific way. Composite systems reduce the total weight of the building and increase stiffness. According to a study by Sharman and Corneri, composite columns can carry 20 to 30% more load than traditional RCC columns of the same size. Composite systems also reduce construction time. In the case study, I reviewed that composite buildings was finished 5 weeks faster than RCC buildings. Faster construction means lower labor costs and earlier use of building, which saves owners money. Another key point is the material choice matters and the impact it has on this case study. The case study compared the two 22-story mixed-use high-rise buildings with parking in the basement and living spaces above. The composite building used smaller column sizes, which created more usable floor space. That's a major advantage in high-rise design. Safety is another major reason why material choice matters. A stiffer system reduces sway, which makes the building feel safer for the people inside. Composite systems also perform better during earthquakes because the steel and concrete work together to absorb the energy. Another factor is the maintenance of RCC structures can crack over time, and steel structures can corrode if not protected. That's why composite systems reduce the issues because the concrete protects the steel and the steel strengthens the concrete. Climate also affects material choice. In hot areas, concrete expands and can crack. In snowy places like Minnesota, buildings need materials that can handle heavy loads. Composite systems adapt well to different climates because they balance strength and flexibility. Some engineers still prefer RCC buildings and it's cheaper and familiarity. Others prefer steel because it's lighter, but the research from the Journal of Construction Engineering shows that composite systems often reduce total material use by 10 to 15%, which lowers long-term costs. So after looking at the information, composite systems stand out. They're lighter than RCC, stiffer than steel, and faster to build when constructing with masonry. They give engineers the best mix of strength, speed, and efficiency. One of the biggest advantages is construction speed. The case study showed that composite floors and columns allowed crews to work faster together, and reduce the delays. Finishing 5 weeks early is a huge benefit to the construction industry. Composite systems also help the environment because they use less material and weigh less. They reduce waste and lower the carbon footprint of the building. Lighter buildings also require smaller foundations, which saves even more resources. You might be wondering how composite systems actually work. It's simple. Steel is placed inside the concrete and the two materials bond together. The steel handles tension and the concrete handles the compression. It's basically a 2-in-1. When following these types of construction rules, you can see that as the technology grows, engineers need materials that can keep up. That's why composite systems help us build taller, safer, and more efficient structures. They're becoming a major part of the future of construction. Thank you for watching this video. As engineers